In these next couple of videos, we're going to get into doing problems with properties of exponents, which basically means taking problems with lots of exponents in them and cleaning them up and making them look nicer. Before we get too far into things, I have 3 ground rules that I'm going to go over with you guys that you use pretty much in all exponent problems. So these are just 3 things you need to be aware of, and we'll practice with them before we get too in-depth with all the rules. So the first ground rule right here is going to say every single variable, every single coefficient has its own exponents. And if you don't see an exponent on something, the exponent is equal to 1. So if you look at this first example right here, we have 4x y to the third times z. All that is being multiplied. There's really an exponent of 1 on the 4. There's an exponent of 1 on the x here. Y already has its own exponent of 3, so that's fine. And it's really z to the first. Same thing over here. 2 has its own exponent, x, 3. Everything there has its own exponent of 1. Seems like kind of a silly rule to really emphasize here, but kids will forget this later on down the line. On this last one, this 6 needs a new exponent, the y needs an exponent, and then there's another exponent outside the parentheses here. We'll learn how to deal with that in a later video, but for now, just realize there is a 1 on every one of those. Our second rule is kind of it's one that gives kids a little bit of trouble at first, because you're used to saying anything times 0 equals 0, like 6 times 0 is equal to 0. It turns out, though, that if you raise a number to the 0 power, you always get the answer of 1. So this is actually a problem right here. If you have a calculator, you can try it out. Like I'm going to do 4 to the 0 power right here, and my calculator tells me it's equal to 1. You can type any number to the 0 power, and you will always get 1. This rule actually makes complicated problems a lot simpler just by realizing it. In a later video, I'll probably explain why that rule works, but for now, we'll just kind of take it on faith here. So 4 to the 0 power, like I just said, is equal to 1. This one right here, we know that x to the 0 power is really a 1. But don't forget, 8 has its own exponent here. That 0 isn't for the 8, it's just for x. So what we really end up with here is 8 to the first, which is just 8, times 1. We end up getting out an 8. So you got to be careful. 8 has its own exponent there, so it didn't turn into a 1. You get 8 for that one. And this third problem here looks extremely complicated. There's lots of stuff going on. There's a pi, there's variables everywhere. But everything inside that parenthesis is being raised to the 0 power. And like we just learned, anything to the 0 power, no matter how complicated, is equal to 1. So this whole messy thing right here is really just a 1 in disguise. This takes us to our third rule for the video, which out of the 3 is the one that requires the most practice to get used to. But it has to do with the idea of a negative exponents. If you have a situation with negative exponents, you're actually going to move them to the other side of the fraction and turn them into positive exponents. You're not allowed to leave negative exponents typically in your final answers. So, best way to practice this is through a couple examples here. If you look at the first one, we have to decide where my negative exponents are. So in this problem, and actually I'm going to go ahead and change the second one, make that a negative there. We'll come back to that though. So in this first problem here, 5 has its own exponents of 1. So 5 is totally good right where he is. He has a positive exponent. X to the positive third, totally fine. Y to the negative 7th though is a problem. He has a negative exponent. He's going to have to move. We'll get to that in a little bit though. On the bottom here, remember 4 has its own exponents of 1. So 4 is good right where it is. But this z also has a negative exponent. It's going to have to move to the other side of the fraction. So once you decide what has to move, the y is going to get moved down here, and the z is going to get moved up here. So in this problem, they end up just trading spots. I'm going to rewrite my final answer now. I have the 5. I got my x to the third. And that z to the negative 2 is going to pop up top here, because it was a negative exponent. It's going to turn into z to the positive 2, like that. On the bottom, I have my 4, that didn't move, and this y to the negative 7th moved down below. So it'll be y to that positive 7th right there. This has no negative exponents in it. That is a final answer for that problem. On my second example here, this is a one I added that negative sign earlier because kids mess that up a lot. This number being negative doesn't matter to us. That's totally fine. Numbers can be negative and it's not a big deal. The rule is when the exponents are negative. When you have a negative exponent, you have to move it. Numbers are fine right like they are. And you might say to yourself, well look, negative 10 has that negative 6 for the exponent right there. But remember, every number has its own exponent. That's really a negative 10 to the positive first. So that stays right where it is. Negative 10 does not move in this problem. I'm even going to write it over there now. So positive 1 exponent, leave it alone, even though the number itself was negative. X has to move, though, because X does have a negative exponent, as do Y and Z. The 3 is to the first power. It's cool right where it is. So when I move my variables around, Y to the negative 5th pops up top, turns into a positive 5th. Z to the negative 4th becomes Z to the positive 4th. X to the 6th is down here, and there's that 3 still. So this would be my final answer in number 2. Alright, 2 more problems in this video. We got 3 to the negative 2nd power right here. Now, we talked about how negative exponents go to the other side of the fraction, but there is no fraction in this problem. Well, that's really because it's really 3 to the negative 2 over 1. And now we can move this over. The 3 is going to get sent to the bottom right here. So there's nothing left up top. When there's nothing left up top, you're going to put a 1 up there, because it was really 1 times this went away. So if everything goes away, you just put a 1 there. And I can keep the 1 if I really want to, times it'll be 3 to the positive 2nd. This 1 is really kind of useless for us. 3 to the positive 2nd power is 9, so this is really equal to 1 over 9, if you were to do all the math. Some people might look at that original problem and be like, oh, if 3 to the 2nd is 9, then 3 to the negative 2nd is negative 9, but it doesn't work like that. And if you type that in the calculator, 3 to the negative 2nd power, your calculator gives you a decimal, 0.1 repeating right there. That's exactly what 1 over 9 is equal to. So you can see that it actually does work out. Alright, last problem in the video. Again, no fraction bar, but we have a negative exponent, so we're going to put it all over to 1. This whole thing in parentheses is being raised to the negative 4, so this whole thing in parentheses gets moved to the bottom. Nothing left up top, so I put a 1. And the bottom is going to be that parenthesis guy, and I'm going to change this negative 4 to a positive 4. In a future video, we'll learn that there's more you can do with this problem, but for now, that's good enough for us.